Welcome, my dear learners. Today we are looking at limits of a function. The concept of limits or limiting process is essential to the understanding of calculus. In this session, we will first illustrate the concept of limits by numerically studying the behavior of the function for values of the independent variable approaching a given number. Now, we are going to use what we call the intuitive approach or the table method, and then the algebraic approach to evaluate the limit of certain functions. So the method that we are going to use here are now to start with the intuitive approach. So let's start with the intuitive approach. So to start with the intuitive approach or the table method, let's consider the function. So let's consider the function f at x, which is equal to x squared minus x plus 2 for values of x near 2. So it means we are going to use the table method to find the limit of this function as x gets nearer and nearer to 2. For us to get a clearer view of the values of x as it gets nearer and nearer to 2, it will be very appropriate for you to draw your number line. So let's draw the number line. And then locate where 2 can be found on the number line. So let's take it that 2 is here. Now in finding the values of x, we are going to look at the values of x approaching 2 from the left, and then values of x approaching 2 from the right. So values of x approaching 2 from the right. So let's take it that values of x approaching 2 from the right. So we have it x is greater than 2, and then values of x approaching 2 from the left. So you have x is less than 2. So what we are going to do is we are going to write numbers that are approaching 2 from the left, and then values of x approaching 2 from the right in a table form. So what are the values that we can locate as x is approaching 2 from the left? If we are having 1 here, so we can say that we can pick values such as 1.0, 1.5, 1.9, 1.99, 1.999, 1.99999, 1.99999. The most important thing is the value of x should not be equal to 2, but we can pick values of x that are closer and closer to 2. So we are going to draw our tables and write down the values of x approaching 2 from the left and then from the right. So the values of x approaching 2 from the left, we can get 1.0, we can also get 1.5, we can also get 1.8, 1.9, 1.99, 1.999, we can also get 1.999. We can move on. So far as we are not getting exactly equal to 2, we can move on. Now let's list the values of x approaching 2 from the right. We can get values such as, if we are having 3 here, we can get values such as 3.0, we can get 2.5, we have 2.1, 2.01, 2.001, 2.0001. You can also get 2.00001. and then lastly we can also get 2.0000050 and then 1. And then what we are going to do is that we are going to compute the value for this using the function. So let's write the function here. So the function is s squared minus x plus 2. Then we have s squared minus x plus 2. So we are just going to evaluate these values of x into the function. So it is very simple. You just have to use your calculator. Let's punch it. So we are going to use, we have alpha x squared minus alpha x plus 2. That is the function. And then after that we press what we call calc or solve. So the value for x, the first one is what? 1.0. So we are going to get 1.0. What are we getting? We are getting 2. So we write it down. So at s is equal to 1.5, so we have is equal to 1.5. We are having 2.75. At 1.8 we are getting 3.4400. At 1.9 we are getting 3.71000. At we are done with evaluating the value of x approaching 2 from the left. Now let's look at the value of x approaching 2 from the right. Let's evaluate it using the same function. So you can still use your calculator. We have the function here, so you just have to enter the value for x into the function. So we have still equal to, we are getting, the first one is 3.0 and we are getting what? 8. So we are going to write, the first one is giving us 8. At 2.5 we are also getting 5.75000. So from the table we can observe that as the value of x approaches 2 from the left, that is the values of x approaching 2 from the left, we are saying that the limit of the function is approaching a certain value, and that value is what? 4. Now when we come back to the values of x approaching 2 from the right, that is approaching 2 from the right, we can see that the limit of the function is approaching a certain value, and that value is what? Is 4. So it means that on either side of 2, the values approaching, we can see that the limit of the function is approaching 4 on either side of 2. In fact, we can make the function get closer and closer to 4. This function get closer and closer to 4 by taking x values sufficiently closer to what? To 2. We can now express this by saying that the limit of the function f at x, so we can say that the limit of the function f at x, which is equal to x squared minus x plus 2, as x approaches 2 on either side of 2, is equal to what? 4. Now generally we can say that in general we can say that the limit of the function f at x as x approaches a is the value x is approaching, is equal to what? The limit. So in summary, in finding the limit of a function as x approaches, we never consider x being equal to a. X should never be equal to a. Should not be equal to a, but we can make x get closer and closer to what? To a. That is the limit of a function. Now we are going to take one more examples and then see how best we can use the intuitive approach to find the limit of such function. So we have the example. Using the table, find the value of the limit x minus 1 all over x squared minus 1 as x approaches what? 1. The limit of this function as its argument approaches 1 from either side of 1. So as I said, to serve as a guide, you can draw your number line, locate where 1 can be found. Let's take it that 1 is here. So we are going to look at values of x approaches 1 from the right. So values of x approaches 1 from the right, that is x is greater than 1, and values of x approaches 1 from the left, that is x is less than 1. So this one is from the right and this is what? From the left. So after getting to know that, you draw your tables and then you write the values down. So the values of x approaching 1 from the left, we have 0 here, so we can get 0.5. We can also get 0.9 approaching 1 from the left. We can also get 0.99. We can get 0.999. We can get 0.9999, and so on. We can also get value approaching 1 from the right. So let's take it that we have 2 here. So approaching 1 from the right, we can get what? 1.5, 1.01, 1.0. Okay, now that we know the value of x approaching 1 from both left and right, let's evaluate these values of x with the function. So what we are going to do, we are still going to use our calculator. We punch the function into the calculator and then we find the values. So at x is equal to 0.5, when you substitute 0.5 in place of this function, we are getting what? 0.66667. Now at x is equal to 0.5, we are getting 0.5263. Now let's move on to values of s approaching 1 from the right. So the same thing, at s is equal to 1.5, we are getting 0.4. So we have 0.4. At s is equal to 1.01, we have 1.01. We are getting 0.4975. So from the table, what can you observe? From the table, we can observe that as the value of x is approaching 1 from the left, the limit of the function is approaching 0.5. Now when we look at the value of x approaching 1 from the left, that is this value, we can observe that the limit of the function is also approaching 0.5. So we can say that from the table, we can say that the limit of the function x minus 1 all over x squared minus 1 as x approaches 1 from either side of 1 is equal to 0.5. We are done for the day. Thanks for watching. In our next video, we are going to look at using the algebraic approach to evaluate the limit of a function. Bye.